Okay then, next there's a train here. There's also a little box, something over there. Let's look at the train. Go look at it. You don't look at the train, is he? Why is it here? More game they couldn't be bothered to finish. Well, I'm not complaining. The sooner this is over, the better. Let's look at that phone box. The phone box there. They put it in a bloody awkward spot, haven't they? Such an awkward spot, you cannot click on the phone box. Get back in there, you dickhead. In. Get that phone box. Bastards, you can't click the train, can't go in the train, can't do nothing with the train. It's just there for no reason. Oh, I can click on books. Land of the Midnight Sun. Ah, Midnight Sun. During the day, the only visible star is the sun. This huge spinning ball of hot gas is our nearest star. It shines because it's incredibly hot. In fact, the sun's core reaches an incredible 14 million centigrade, 25 million Fahrenheit. So its energy reaches us as sunlight. Without this, the Earth would be a cold, lifeless place. The sun's diameter is about 100 times that of the Earth. Energetic sun. Seen through special telescopes, the sun's surface looks like a raging fire. Fire don't look like that. It looks like... oh, it's like a lava. Giant ball of lava. Maybe not. Maybe it's not lava, because lava is molten rock. Would the sun be molten rock? Maybe. Like the Earth here. If all the rock and all the soil and all that caught on fire, everything, it would remain on fire. Mind you, with the atmosphere, it might dry it out. Maybe it would just become a place like Jupiter or some place, just a barren rock. Anyway, day and night. Any time, half of the world is in darkness at night, and the other is in daylight. Facing the sun, however, the number of hours of daylight anywhere in the world varies through the year. At the Earth's poles, it is never quite dark in summer, and never quite light in winter. It varies least on the equator, where there is always about 12 hours of daylight. Night time. The bright lights of New York City come on at night. At the same time, it is day in India. Seasons. Our planet is always tilted at an angle of 23.5 degrees. As the Earth spins around, different parts face the sun's heat. This gives many places on Earth 4 distinct seasons. Warm summers when they are facing the sun most directly, cool winters when they are turned away, spring and autumn occur when a part of the world is moving between the two positions. Earth, sun, path of Earth around the sun, all change the orbit of the Earth and is slightly tilted to create different seasons. All the way round. Anything to click on? Don't know what this yellow pencil case holder is. Don't seem to be clickable. Did we click on the machine? Aha! Fresh something. More magnets, more iron filings. Mixtures. Many substances around us are actually mixtures of other things. Some mixtures can be separated easily and others cannot. If you add vinegar to baking soda, the mixture will fizz and change to make a new substance. This is called a chemical reaction. Two things cannot then be separated. If you mix sand and salt together, the sand and salt can still be separated, even though it would be very difficult to do so. Iron filings cling to magnet. Magnetic separation. You can separate a mixture of iron filings and yellow sulfur powder using a magnet. Yes, and then they're yellow iron filings. Dissolving. When you stir salt into water, the salt seems to disappear. In fact, the salt dissolves in the water. The salt is known as a solute. The water is known as a solvent, and the mixture that results is known as a solution. Solutes can be solids, liquids, or gases. There are many liquids that are good solvents, but water is the best. Substances that dissolve are said to be soluble, while those that do not are insoluble. Stirring in sugar. Stirring solid helps a solute such as sugar to dissolve quickly. I thought this little bastard was doing a science experiment. No, he's just putting sugar in his tea. You lazy fucker. Separating mixtures. Mixtures can be separated in different ways. Sieving, for example, is a good way of separating solids with particles of different sizes, like salt and peas. The holes in the sieve must be large enough to let one of the solids through. but not the other. A mixture of soil and water can be separated using a filter, and a mixture of sugar and water can be separated by evaporating the water off, leaving the sugar behind. Soil particles trapped by filter paper. Mud falls to bottom of flask. Using a filter, muddy water can be separated by filtering. Filter paper is used to trap the mud as the mixture passes through. Put in the bastard tea. What's this? Newport, Greenhill, Littleton, Whitecliff. Can't click it. Can't click it. Let me out. Can't click that. Can't click that. Can't click nothing. Departures. Damn you, train. Can't click it. Click that. Mirrors. Any shiny surface is a mirror. Though nearly all the mirrors that we use are made of glass with a shiny backing, most mirrors are flat, but some mirrors have curved surfaces. Concave mirrors which curve inwards are often used to make things look bigger. Convex mirrors which curve outwards give a wider view of a scene. Curved surfaces. This plate is a concave mirror. It makes the apple look larger. The spoon is also a mirror. Oh yeah, look. It's like it's sitting on a giant apple. See? Giant apple. Reflection. Light travels in straight lines. So when light rays hit a mirror, they bounce off it, allowing you to see yourself. This is called reflection. Most of the objects around us reflect some light, and we see them when that light enters our eyes. Surfaces that reflect all the light that falls on them appear white, while surfaces that reflect no light look black. Image, image, mirror, image. A reflected image in a mirror will look back to front. Look at it. It's the wrong way round. You see his wrist. Revealed his wrist. Can't go through the door. Can't go anywhere. Oh, it's just a picture. Stupid machine. Talked about iron filings instead of coffee. Looked at that garbage. Look at that shit. Looked at this shit. It looks like we're done in this place. Oh, the brain hidden over here. Tell me about my brain. Understanding your brain is what will blow my mind. I think I've read about the brain already. I'll read about it again. I don't know if I have. Your brain is your body's control center. It controls how you move, breathe, make sense of the world around you. Different parts of your brain do different jobs. Some parts receive information from your eyes, ears, hands, and the rest of your body, and then send signals to your body to make it move. The information signals are carried by your nerves. Side view of brain. The outer surface of the brain is folded massive nerve cells called the grey matter. Blech. Lump. Big lump of goo. Your nerves are like wires made of bundles of living cells called neurons. They carry electrical signals to and from your brain and every single part of your body. The main pathway for these signals is your spinal cord. Nerves branch out from your brain, spinal cord to all other parts of your body. Your brain, spinal cord, nerves together are known as your nervous system. Probably in the future, they'll just cut off your head, stick your fucking spine in a computer, and you'll be wandering around with a monitor on your head. Well, you won't have a head, actually. You'll be tossed in the garbage. Or eaten. Probably eat it. You won't need a mouth to just pump it directly in your stomach. Ooh, look, stairs. What's up here? Ah, we found a new space. Hidden door. Ah, okay, found a factory. Can't look at that. Ah, medical chest about viruses. Don't you tell about bandage or fucking medical care or anything? You tell me up. You left. Exited through the same door. Do you not educate me? Historical gardens with writing too tiny to read. That's good, I'm glad. Inside a flower. We've learned about you flowers. Dirty little flowers. It's a dirty little flower and a dirty little hummingbird eating the dirty little flower. And the coin-shaped seeds. What the hell is a coin-shaped seed? Honesty seed. Right, honesty seed. Try and remember it. Oh, I looked for coin-shaped fruit earlier, but I couldn't find it. Honesty seed. There's nothing in this shithole other than stuff I've already read. No, printing press. They don't tell you nothing about the printing press. They don't tell you nothing about trains or the printing press. You know what I think? Look, historical gardens. Let me tell you about a flower. I think what they did was they gave up halfway through. Well, not halfway through. They gave up near the end. They probably just needed to piss it out. So what they did is they duplicated some of them. They didn't make the part for the gardens or the medical chest. They just add viruses here, viruses there. What's in this? What's that? Something new? Oh, good. Solar system. The word solar means that something has to do with the sun. The solar system includes 9 planets, including Earth, and millions of asteroids, comets, and meteoroids. All of these objects spin around, orbit the sun, which is the center of the solar system. Most of the planets have moons, and they too are part of the solar system. Spinning in space. Wee. The planets. The 9 known planets in our solar system are divided into the rocky inner planets and the icy outer planets. Each planet travels around the sun, and closer to the planet is the sun, and less time it takes to complete its orbit. Scientists believe the planets were formed about 5,000 million years ago from material left over from the sun's birth. A total of 9. There are 4 inner planets and 5 outer planets in our solar system. Sun, Mercury, Venus, Earth, Mars, Jupiter, Saturn, Uranus, Neptune, Pluto. Yes, great, wonderful. Next, look at the hourglass. Tells us about sundials. Right. Oh, time, I get it, time. Nothing about an hourglass, though. Telescope. Yes, the moon watching us. And Maria. Tell us about Maria again. Maria. What's in here? A knight. Tell us about a knight. Rusting. Poor bastard. Iron and steel objects go rusty if they are left in a damp place. A bicycle left outside in the rain for too long will rust. Water and oxygen are mixed with iron and change it to a red-brown rust. Rusting weakens the metals, so they eventually crumbles away. Rusting is an example of chemical reaction. During a chemical reaction, materials combine and change to make new materials. This change cannot be undone. Preventing rust. Armor was polished with beeswax to stop rusting. Yes, the poor bastard out in the rain. Oh no, I'm rusting. Chemical changes. Chemical changes are also known as chemical reactions. During a chemical reaction, the atoms of substances rearrange to form completely different substances. For example, when wood burns, it reacts with oxygen to produce water. Carbon dioxide and smoke. Chemical changes cannot be reversed. The non-chemical changes can be reversed. For example, when water freezes, changing from liquid to solid. Yes. Burning wood. Once wood has burned, the change cannot be reversed. Wrong. Reverse time. Oh no. Once wood has burned, the change cannot be reversed. I guess that's true. Or is it? I'm thinking, maybe if you crush all the little bits of ash together really tightly, you'll get the wood back. But to our knowledge, you can't, but maybe it's possible. The scientific term for burning is combustion. During combustion, one substance combines with oxygen to produce new substances. For example, burning wood combined with oxygen from the air to produce carbon dioxide, water, and smoke. Combustion always produces heat and often light, as in a burning candle. At first, the flame burns brightly. The flame goes out when the oxygen is used up. Oxygen to burn. To burn a candle needs oxygen. When the oxygen in a jar is used up, the candle goes out. No! It died. Poor candle. What's that switch? Oh, we're going in an elevator. Aha! This is where the budget went, on this elevator. Let me out. Turn around. Turn around again. Turn around again. Ooh, look. Microwave. Is that that's a radio. Alright, tell me. Sound. Sound is invisible. It travels through different types of materials at different speeds. Most sounds we hear travel to our ears through the air. All sounds are made by objects moving backwards and forwards or vibrating. When you hit a drum with your hand, you can hear the sound of the vibration as well as see it, feel it. Bang the gong. Striking a gong makes it vibrate. This produces a loud sound. Yes, it vibrates the air. You told me earlier. Loud and quiet sounds. Some sounds are very loud, while some can hardly be heard. The sound of a jet engine is louder than a whisper because a jet engine produces large vibrations in the air. The loudness of a sound also depends partly on how far away the source of a sound is. Loudness is normally measured in decibels, dB. Decibel scale. The loudness of the sound is measured on the decibel scale. A sound of 0 decibels can only be heard by dogs. 20 decibels. A leaf. The leaf can hear 20 decibels, I think. Or is that what we make? What is this diagram? I don't even tell you what it means. This is the sound. Children make 40 decibels. Cars make 80. Leaves make 20. Drums make 100. Jet engine, I guess, or rocket makes 120 decibels. Is that the maximum that we could make? The leaf can make 20 decibels, half a human. A leaf can make the sound half of a human can. Can it? How? Some sounds are high and others are low. When a dog growls, it makes a low sound, and when it whines, it makes a high sound. High and low sounds are also called high-pitched and low-pitched. The pitch of a sound is how high or low it is. Some animals, like bats, make very high sounds that are too high-pitched for humans to hear. Look at these. Look at their faces. Looks like they've been listening to Woody for hours. Now they've gone brain dead. Sound in a bottle. As the air inside these bottles vibrates, each bottle produces a note with a different pitch. Echoes. Sound can reflect or bounce off objects. An echo is a reflected sound. Sound reflects off hard, smooth surfaces better than soft, rough ones. It can travel through air at a speed. Is he clapping? Of about 140 m, 1,115 feet every second. If you stand approximately 40 m, 31 feet away from a wall and clap, your hands will hear an echo less than a second later. Bouncing sound. Clapping loudly near a brick wall will produce an echo. Let me find a wall. I'll use my monitor. Yeah, it's echoing. Yeah, it's echoing off me. Clapping produces sound waves. Sound reflects off wall and returns an echo. Sound is made when an object moves backwards and forwards or vibrates. As the object moves, the air around the object also vibrates. The vibration travels through the air as sound waves. Sound waves are invisible. Patterns of air molecules squashed together or further apart like ripples in a pond. Air molecules squashed together. Tuning fork vibrates and produces sound. Sound wave. Air molecules further apart. Tuning fork kills sound waves. Saying sound waves. The sound waves from a tuning fork and air molecules seen here. Can't click on the picture, or the stall, or the coffee cup, or the paper. Nothing. Let me out. Let me out. Where's the way out? There's no way out. No way out. Won't let me leave. Pot. Melting. There's a pressure. It looks like a pressure cooker. What's the pressure cooker got to do with melting? See, they got lazy, these bastards. Didn't tell you about the pressure cooker. What's this? Heat.
When you heat water or another liquid in a saucepan, the energy it absorbs makes the liquid get warmer. Tiny particles, called molecules, which make up the liquid, start to move faster and further and take up more room. If a liquid is heated to a high enough temperature, it boils and the molecules move even faster. At the same time, some of the liquid becomes a gas or vapor. The boiling liquid will not get any hotter, even if it is still being heated.
Oh, really? I think this would be more appropriate for that thing on the stove I clicked on. Heat is a form of energy. All objects contain heat. A cold object simply has less heat than a hot one. All objects are made up of tiny particles called molecules. Heat energy comes from the vibrating movements of these molecules. As a substance is heated, the molecules move faster and substance becomes hotter. On the movie, the atoms and molecules of a substance move faster as it is heated. Right. Temperature. The temperature of something is a measure of how hot or cold it is. The hotter something is, the faster its atoms move. Temperature is normally measured in units called degrees Celsius or degrees Fahrenheit. Water freezes at a temperature of 0 degrees Celsius, which is the same as 32 degrees Fahrenheit. 100 C. Water boils. 100 C, 212 Fahrenheit. 60 C, 140 F. Cup of tea, 37 C, 98.6 body temperature. Unless you have solar hands. Hot summer day, 30 C, 86 Fahrenheit. 10 C, 42.18 Fahrenheit, cold drink. Water freezes, 0 C, 32 Fahrenheit. Did I read that? Thing to the right there, I don't know if I read it or not. The temperature of something is a measure of how hot or cold it is. The hot something is the fastest atom moves. Temperature is normally measured in units called degrees, Celsius, degrees Fahrenheit. Water freezes at 0, which is the same as that. Temperature scale, the same as the temperature of somewhere. I think I read it. Thermometers. Thermometers are special devices used for measuring temperature. The two most common types are electronic thermometers and liquid and glass thermometers. The electronic type contains a probe that is sensitive to temperature. The liquid and glass type contains a liquid that expands and contracts as the temperature changes. This liquid is normally a silvery coloured metal called mercury, but sometimes a red coloured alcohol is used. Yes, you can drink it. Electronic thermometer, liquid crystal display, electronic probe for probing, liquid and glass thermometer, temperature scale. Liquid expands as temperature rises. Measuring temperature. Electronic thermometers show readings as a digital display. Alcohol is the liquid used in liquid and glass thermometer. Is that it? Nothing else? What's in door number 2? Ah, we're free. We're out of this shithole. Is there anything else to do then? Let's go back. Get ready, you gotta listen to the thing. Turn the speakers off actually. There we go. I'll save you the agony. Little bastard. 38. So we've got 4 to find. Ooh, where are they? Where are they? I don't know. Where would they be? I think there's one over here I didn't see. Like that mixing. Probably that as well, that thing, what that is. Night seasons. I think I've seen all this. It's the rusting. The birds, did I click on the bird? Yeah, I think so. This is that train place. I think. Alright, let's just go back to Science City and find it. The one in here about water pressure or whatever, I don't know where the fuck it is. Clicked on all this shit. Clicked on the glasses. This thing, I think I clicked on this as well. Colour, yeah, light, whatever, travels from prism, turns to rainbow. It went up there. Where the fuck am I now? Oh, bollocks. Four to find. Yeah, I don't even tell you which ones you've done. Damn you, Woody. Annoying motherfucker. I've done all this garbage. I think I did everything. Everything I can find. I don't. Everything in here I did. See, I've been everywhere. I don't know where it could be. Done that, done that. Done that, done. See, you don't even, you can't even. What's? Is there something else there? No, it's the same shit. Done this. Back in the elevator. That's where the budget went in that elevator. Where's the birds? That thing hidden. Tells you about birds. There you go, found one. Even though I've already read it. Hidden, the bastards. Scumbags. Whatever, that's one more. Oh, hidden as well. The Earth. We know about the fucking Earth, though. Yep, we know about that. That's 2. Did the Earth, Moon. Fucking crap. Oh, a tap. Hidden tap. Hidden tap, motherfuckers. Water pressure. We learned about bloody water pressure.